by Uptime Institute. It might be a different game. So I think no more to say other than introduce CSC, basically the anchor case in Kayani. So welcome, and CSC supercomputing vision.
Hello. So my name is Marjut Andler, and I'm a director for business development at CSC. And CSC, as many of you have heard multiple times during this workshop or conference, that we have been the first data center here in Kayani. We made this bold decision in year 2010. And it has been a pleasure to see that many big companies are now following, so our argumentation or decision making was not totally wrong. It has also been discussed that there are hundreds of data centers in Finland and of course around the world, but there is only one plus data center in Finland, or I mean supercomputer center in Finland, and it's CSC. So we are very special as a data center. And when I say one plus, there is also another supercomputer in Finland that is the Finnish Meteorological Institute, but it's for a special purpose. So we have multiple customers and multiple purposes for which our supercomputer is used. And I have only been 2 years at CSC, and mainly before that I was for almost 30 years in the normal IT, so to say. And it was supercomputers were not so much discussed. So this is a very special branch of IT, and special competencies are needed in this field. I don't know whether it's correct, Peter can correct me if I'm wrong, but I have understood that these supercomputers, they are the princesses of the computer, so they can be one-off, they are unique, and they are driving the hardware the development further, and new things are tested in this environment. So it's not normal IT. And therefore we had some difficulties thinking about this conference and what to speak to you. Can I ask the question that how many people in this audience are somehow supercomputer connected? I see 1, 2, 3, 4, 5, 6, maybe less than 10 people. So that was what we were kind of guessing, and what is your interest, what do you want to hear from us? So we tried to make a presentation that gives you something but does not go too deep, and of course we only have 20 minutes. So we have a shared service. I will start, and Peter will then continue with the more technical part of it. I have been part of the steering group for 2 years during this data center project of CSC, and it has been an interesting journey because it is about partnerships. It's very much about partnerships, governmental and commercial, it's local and global, and it's IT industry coming together with paper industry. So there have been lots of things that we have learned during this journey. So now I need to do something with this one. That one. So the agenda we have, what we decided, just very briefly tell about CSC, and then something in between which we added this morning. So this is our mission. We are part of the Finnish national research infrastructure, you could also call it. So when we continue further, it's a company that has been there for more than 40 years, and it is 100% owned by the state. And the facts you see here too, and the faces you see here. Our services are like computing services, which is the supercomputing part, and some additional things. And then it's networks, like Funet network, and then data services, which is the growing part for us very much at the moment. And our customers, you see there is universities, universities for applied sciences, and then other governmental organizations. But we are very much focused in this research, education, and culture. In addition to the national activities, we are taking part in many EU projects because science is international. It's born international now, and that's how it's going to be. We need to be involved within European projects and also globally, so that we are there to form standards and somehow ensure that there is interoperability between the systems and formats and standards and whatever, so that our researchers can easily take data from other countries and other researchers. Then this is the additional slides we added, so thanks for the organization quickly updated materials here. So when listening to these presentations yesterday and today, I'd like to talk about research, education and culture infrastructure vision. Now the topic for today was supercomputer vision, and we don't have the time to talk through all of these, but it's really the combination that matters. So that we have the supercomputers, we have the big data or the storage available for the research data, and it's stored in such a way that the researchers can find it, that the metadata structures are in place and they are standard. We need to have a good network and we need to have expertise. All of this is needed, and this total thing needs to be optimized. And then talking about our country and our government, I think I have seen it now during the past 2 years within CSC that there has been a lot of good work done with our taxpayers' money. So maybe now talking about the expertise part, which has maybe been missing in this presentation. So expertise is needed, people are needed, although we need the technologies. But when thinking about Finland, we have a very good basic education for everybody, and for a long time our schools have been teaching us languages, because our language is such an old one, nobody would understand us with that one. So we also have had IT at schools since the 90s. The schools have been networked, they have workstations, and the teachers are trained so that they can integrate the IT into their teaching or the lectures. We have practically free higher education, so people can continue as long as they are motivated. So it's not about the wealth of the family, so everybody has an opportunity. And then also about this support to research, education and culture. Finland was connected to internet in 1988. I don't know whether it was called the internet at that time, but that was very early years when it was only for research use, or maybe also this war industry. But anyhow, this was the fact that we had to do this because research is international. And Funnet has been there for a long time. The supercomputer investment is there, the data center is there, and now we are talking about data. There is a big initiative about research data. So because of all these background things, we have been said that we are early adopters of new technologies, and that Finland is a national IT laboratory. It's not only a few persons who utilize the new technologies, but it's utilized community-wide, and new innovations come from that kind of a situation. And I think these are enablers for Finland. We are a very, very small nation, so this is the way how we can be successful in the digital economy in the future. And my last point is that we are a state-owned company, and we need to be green. And we have a green office, green data center, and almost green personnel talking like Martians sometimes. So good that we are green for the environment, but we have also seen that it's the cost-efficient way of operating a data center, because electricity is the main operating cost for a data center, and if we are green, we are also cost-effective. Then we go to the details.
Okay, I'd like to use this mic here. Great. So I just wanted to pick up on the theme that Marjut introduced. So really CSC is about maintaining Finland's competitiveness in the sciences and research area. So my name is Peter Jenkins. I am a system specialist at CSC. I've been involved in the data center deployment project and the recent IT procurement for new supercomputers over the last 2.5 years. And it's been an interesting ride. So I'll try and go through some details, but just to emphasise the range of customers that we deal with. So we are focused on general purpose supercomputer services for researchers in different areas. There's no one area that's particularly dominant, and each of these sciences have applications which have large data sets, and they also have applications which have very small data sets. They have different kinds of performance requirements. I suppose the only common thing you could say is that they are a good fit for a location like Kajaani because they're not latency sensitive. Typically, scientists work on complex models. They run long-running analysis and they come back and they refine the models and repeat the process. To pick up on the point of FUNET, division within CSC that does not provide high-performance computing, it provides high-performance networking, and the infrastructure links all the universities in Finland to our customers. So Kajaani is right in the centre of our network and has been since the 80s. Speaking of history, then, this is the original systems from 40 years ago. This chart goes back as far as 1989, when the top 500 supercomputer, 1993, when the top 500 supercomputer list started, and a little bit before, it's conflicting information. It's a message slide, but the two things I really want to show is the continual improvement in performance. This is an exponential scale. Showing the increased performance, the red line being what we have available, and the blue line what's been used by our customers. For every new machine we buy, then the researchers do more detailed analysis, more science, more simulations. And the bottom graph shows the top 500 ranking of our best system in any given year. And it's pretty obvious that what can be a very competitive system 1 year rapidly drops off in international competitiveness, and this is a problem for scientists if they need to compete on an international scale. So we have this continual refresh every 3 to 5 years, going back some time, and you can see here the most recent system. So the previous generation system stood up actually fairly well. It was upgraded a few times and had quite a long lifespan. But typically 3 to 5 years. So, what next? As Marjut said, there was funding given to CSC for new supercomputers in 2010. This should be 2012. And procurement was done to buy new systems to continue the capacity for our customers. And I won't go into the procurement process, but these are the vendors which I'll go into some details. The next largest supercomputer for Finland will be manufactured by Cray and will arrive in Kajaani middle of next month and be bought online through December and January. It's a €10 million 5-year contract with a significant upgrade in 2014. It's a very interesting system. Unfortunately, some of the details are not publicly disclosed yet, will be announced in November. So all I can say is it's a high-density system and is using water cooling. We also have a much smaller research prototype system. I don't want to go into too much detail, but there is an uncertainty in the future of supercomputing around the technology type and also the cooling technology. So we have some quite different ideas, and this one is an EU-funded project in collaboration with several other international sites, which will be hosted in Croatia, and we'll be looking at warm water cooling and reusing of waste heat for heating our office building, our site office building. The other winners was Hewlett-Packard, which is providing a commodity cluster. Many of our scientists don't require the highly scalable nature of the Cray-type supercomputer. They just need a large number of nodes. In HPC, we refer to these applications as embarrassingly parallel. That is, they don't actually talk to each other, they just need resources. One interesting thing which was brought up earlier today is the rack density. So we're using the SGI data center which was presented earlier, and the racks from HP are actually very high density, so 30 kilowatts, and that's not the faceplate, that's the projected real power consumption when running HPC workloads. There's also a considerable amount of storage that's becoming increasingly important for our customers. Almost every area of biosciences, physics is data bound. How long do I have?
4 minutes.
4 minutes. This details, please talk to me afterwards if you are interested. I guess the key thing is the performance improvements. Log is our current fastest machine in Finland. So already we'll see substantial improvements in phase 1, which is this year, and then in phase 2, which is 2014, we'll see a significant increase, and all of that will be hosted here in Croatia. In the interest of time, I will skip the details. There is some innovative packaging happening. Density is increasing, and the suppliers of high-performance computing are looking at different cooling mechanisms. As Mario was saying, we kind of have to be early adopters, and there's some very different approaches. HP's one is very much focused on low-cost scale model from the cloud area. Cray is basically focused on very high-density supercomputing only type product. There's an uncertainty in the processing technology. One area that's driving this is not HPC, but the gaming industry. HPC is a substantial part of the IT industry, but it's peanuts compared to gaming or mobile phones. So we're seeing a big impact in technology. In this case, graphics cards, so 3D graphics cards, have more processing capacity than CPUs. And if you look at energy efficiency per performance metric, this one lower one is regular CPUs, and this is graphics cards. Unfortunately, it's not that straightforward, hence the T platforms research system. It's very hard for scientists to use these different types of processors. They're not really designed for general purpose computing. So it's an interesting time. In the summary of our talk, talked about exascale. I wanted to include that. I'm going to skip it. What I talk about is the science. So there is an insatiable demand in science for more computing power. So CSC expects to continue to improve the performance that we provide, and it continues to be a challenge for our suppliers. And it's not just a challenge from a purely hardware perspective. Actually, the software to utilise these systems is becoming increasingly more complex. So there are far more people in CSC handling, working, consulting with scientists and optimising applications for these large systems than actually buying the systems and operating them. You can look at some typical applications. It would be very nice to model climate change at a much finer detail detail than we can now. It would be very interesting to forecast weather at a block-by-block level inside cities. In almost every area you find that the scientists are actually doing simulation first and experiments later. In the case of astrophysics, it's not possible to simulate create another universe for experimentation. Since we're running out of time, I will skip the technology slide. I wanted to just repeat the message from earlier that you will be touring the facility today, and just to give you some context for those that didn't see the presentation yesterday. The HP system which I talked about is already in place and is currently being installed in this unit. So if you tour today, you will see that. It's not yet operational, but we tested it in the factory and it's working very well. The Cray system isn't yet there, but you can see the room where it's going to. I personally will be running one of the tours and be happy to take questions later. I think the other tour guides know quite a bit about this as well. So I think that's where I'll stop. Thank you.
Unfortunately, we don't have time to hear questions right now. So thank you, Mario. Thank you, Peter. Important, I think, for any location, when you have your anchor tenant in place, important for the ecosystem as it starts to grow, to have an understanding of who does what. So thank you. It was good for us to get absolutely on a level with what you're doing.